26. Assuming that no equilibria other than dissolution are involved, calculate the concentrations of the ions in a saturated solution of each of the following, and see Appendix J for solubility products. So in this case, we have to find out what those concentrations of the ions are in the mineral anglesite, which is PbSO4. I did go to Appendix J for you guys to find out that the KSP, the solubility product SP, is 1.3 times 10 to the negative 8th for PbSO4. But with every KSP number comes a balanced equation. Remember, for solubility, these compounds are starting off as a solid, and they will break down into their ions. So let's find the balanced equation. PbSO4, that's a solid. This comes to equilibrium to find the two ions, right? SO4, I notice that that's a polyatomic sulfate. So the break has to be between the Pb and the SO4. So Pb, Pb plus SO4. Now we just need to find the charges. It probably would be easiest to memorize sulfate's charge, right? We see sulfate time and time again. That's always a -2 charge. And if there's one lead and one sulfate, if the sulfate is a -2, the lead has to be a +2. And now, since their charges, they're aqueous, and the equation is already balanced. So we're good with this. Whoop. Here we go. Okay, now let's take that equation and just write the general KSP, right? KSP equals just the concentration of the products raised to the coefficients. So in this case, it would be KSP equals the concentration of that Pb, 2+, times the concentration of the sulfate, right, the SO4, 2-. Raise them to their coefficients, but both of them always, they only had a 1 in front of them. So you can raise them both to the first, but just leaving them would also be the same thing. The KSP value from the back of the book is 1.3 times 10 to the negative 8th. But the thing is, we don't know what these concentrations are, so we have to give a variable. Now, a saturated solution just means that there's no common ions that are involving the dissociation or the breakdown between these ions. So we're just going to label it as a variable, right? X. And you just have to flow with it with its coefficient. So technically this would be 1x, but 1 times x is the same as just x. And then the same thing here, 1x, but it could just be x. These are now what your variables are for your Pb2+ and the SO4 2-. So this would be x, and this would be x. So let's see. 1.3 times 10 to the negative 8th equals, we have the two x's being multiplied by each other. X times x is just x squared. So take the square root. Get x by itself. Take the square root on both sides. That cancels out the square. And we get x equals, let's see, square root of 1.3 times 10 to the negative 8th is 1.1. If we still have two sig figs, 1.1 times 10 to the negative 4th. And that's molarity. Keep in mind, though, they wanted the concentration of the ions. So we just have to go back to the balanced equation just to see what we labeled those ions, right? Just to see what we labeled the ions. So Pb, 2+, that was just an X value. And the same thing with the sulfate, the SO4 2-. So, since X was 1.1 times 10 to the negative 4th, that's the concentration of both of these. 1.1 times 10 to the negative 4th molarity, and then 1.1 times 10 to the negative 4th molarity. And that is the answer to this. Okay. Woohoo! This question's done. I think we did all the numbers, or the letters, for number 26. So thank you so much for watching. I really hope this helped. Let me know in the comments. Subscribe to the channel. And I hope to seeing you well, I'll be talking to you in future lessons. All right? Come back. We'll have some fun. All right? Talk to you later. Bye-bye.